All right, we're back, 13.2, and we're going to be looking at angles of rotation. Now, just so that we're kind of consistent and clear on how things work, we're always going to start on that positive x-axis, and our angle is going to rotate counterclockwise if it's positive, and it's going to rotate clockwise if it's negative. And we can talk about that red side. That's the terminal side. That's where it ends. So we always start on that x-axis, and we can kind of label our angles. Now remember, just as we do this in force, we know 90, 180, 270, we get back here, 360 every time we go around is 360 degrees. So we can kind of get together what those angles are, those angles of rotation, which way we're rotating, okay? So remember, a good way to go more than once, we can go around, kind of put that little spiral. You can see that we're going 360 and then additional 30, so that gives us a angular rotation is 390. So that gives us the option of rotating around more than once, okay? So what we want to be able to do is draw these and kind of doing them appropriately. Now again, here's some examples for a 320 degree angle. Yeah, we'd start here we go, there's 270, we'd go another 50, so we'd be about right there. And again, we always want to show which way we're going so we know it's a positive 320, whereas this one's a negative 110. Well, here would be 90, go an extra 20 degrees, there we are, there's our terminal side right there. And then 990, oh boy, we got to think, okay, once around is 360, another time around puts us at 720, and then we got to go another 270 degrees. There we go. See the spirals there so we know how many times we're going around. So draw that angle. You got to have that terminal part correct. Always start at the, on the x-axis to start. That's where we go. And then just make sure you have those little spirals if we go around, of course, each time. So, all right. So again, coterminal angles. Now again, as we realize this, there are some angles that end up being at the same spot. So when you do a positive 120 and a negative 240, they actually end. They have the same terminal side. So there's infinitely many. So the way to get that is to simply just add or subtract 360 from your original angle. So here's an example. If we give you an angle of 65, we say, can you give us a coterminal? So angles that end at the same spot. Well, if I add 360, well, that would be 425. If I subtract 360, we'd be at negative 295. So those are angles that are that would end in the same spot. So they're called coterminal. Something like this. What if our angle was negative 120? Well, if I add 360, 240 is one of those. If I subtract 360, negative 480. Those are angles. And there's infinitely many of those that you can find there as well. All right, so the reference angle, of course, is going to be wherever, however quick it is to get back to that x-axis. So that's the reference angle. So we're always getting back to that x-axis, the terminal side to there. So that's going to be the reference angle that we have. Let me give you a couple examples of that so you kind of understand what we're talking about. So here's the angle 135. That's right here. All right, so now the quickest way back to the x-axis is to go here. Well, if we're at 135, that leaves us 45 for this angle. That's the quickest way back to the x-axis, so that's the reference angle 45. Now, if we go negative 105, okay, we're back here. Well, the quickest way back is to go this way, and that's another 75 degree angles. Yes, the reference angle is always positive. Always positive is what that is. All right, let's get another one in there. So if we have 325, that means we started here, we went around, got to here. Well, to get back to the x-axis, we want to get close to 360. We want to get to 360. So again, that would be 35 degrees left. So it's whatever quickest way back. So a good way to think about that is if we're in the second quadrant, take 180 and minus your angle. If we're in the third quadrant, take your angle and minus 180. That'll give you the reference angle. And if we're in the fourth quadrant, just take 360 minus your angle. And obviously, if you're in the first quadrant, you already have your reference angle. So that's a good way to kind of remember that as we go. All right, so now what we're going to be doing is we're going to be plotting some points here. And what we're going to do is we're going to be trying to find the trig functions. Now remember, as we plot the points, this would be the x side, this would be the y side. And to find the r, okay, that's just using Pythagorean theorem. And r is always positive. Now, in this case, y would be positive and x would be negative, and it depends on which quadrant you're in, but r will always be positive. And so the angle we're always going to be looking for is this reference angle that's between the radius here, the hypotenuse, and the x-axis. That's what we're going to be trying to find as we go. So here's an example. This problem right here. Again, we see at the point negative 6, 9, so plot the point, draw the line right back to the origin. And so it's this reference angle right here. That's the one we're trying to find between the radius and the x-axis. So that's the reference angle. We know this is -6. Important to keep track of negatives. This side is 9. So by using Pythagorean theorem, if you take 9 squared, which is 81, plus, well, remember when you square -6, it turns into 36. That gives you 117. So we'll take the square root, and not a very friendly number. So now we got all three sides very easily. Sine is opposite 9 over root 117. You don't have to rationalize the denominator. I'll let you just leave it like that. That's fine. Cosine is going to be the adjacent side over the hypotenuse. So that's -6 over square root of 117. Can make sure you pay attention to that negative. Tangent is opposite over adjacent, which is 9 over -6. Cotangent, of course, is the reciprocal of the tangent. So just flip those around. Secant is the reciprocal of the cosine, so just flippy there. And then the cosecant is the reciprocal of the sine. And there we go. So that's it for 13.2. Go do the worksheets, check them. If you have any questions, let me know. Until next time, I'm Mr. Boone.